Hello students, in this video we are going to learn about carbon and its compounds. So let us start with how carbon occur in nature. So carbon occurs in nature in free state like an element or also in combined state in the form of compounds with other elements. In free state, carbon, you all know diamond, which is very famous, graphite, which we use in our pencil lead. So in free state, it occurs in two forms, diamond and graphite, although there are some more recently discovered forms of carbon, just like Buckminster fullerene. In combined state, carbon occurs in nature in the form of compounds like carbon dioxide, carbonates, fossil fuels like your coal, petroleum, organic compounds like carbohydrates, fats, proteins, wood, cotton, wool. All these are carbon compounds. Our Earth crust has only 0.02% of carbon in the form of minerals and atmosphere on only 0.03% of carbon dioxide. But when we look around, we have a lot of carbon compounds, the food that we eat, clothes we wear, medicine, books, many other things that we use in our daily life. They are all based on this versatile element, carbon. In addition to this, all the living structures, they are all carbon based. Because of this versatile nature, carbon is able to make millions of compounds, and we have a separate branch that study about this carbon and its compounds, which is known as organic chemistry. Now let us learn about the different allotropes of carbon. As we all know that carbon occurs in different forms. So what is this allotropy? Allotropy is the unique property of carbon that it exists in different physical forms. These different physical forms are called as allotropes of carbon. So the different allotropes of carbon are crystalline forms and non-crystalline forms. Crystalline forms in which carbon occurs in the form of crystal. We have diamond, graphite, fullerene. Non-crystalline forms are also known as amorphous forms. Example, charcoal, coal, lampblack. Let us talk about the crystalline forms first. Diamond, we all know diamond very well, that it's the most popular substance which is used in making jewelries. It is the hardest known substance. If you see over here, the 3D rigid structure of this carbon, over here, carbon is connected to, one carbon is connected to four carbon atoms. So each carbon is bonded to four carbon atom. It is making a rigid structure, 3D structure, means very strong structure. The bond between carbon is very strong. There are no free electrons over here, so diamond doesn't conduct electricity. So this is about diamond, the first allotropic form of carbon. Now let us talk about the another one, another form. This one is known as graphite. So each carbon atom over here, if you see over here, this structure is bonded to three other carbon atoms in the same plane, giving it a hexagonal array. If you see over here, we can see a hexagonal array. One of these bonds is double bond, and thus valency of carbon is satisfied. We'll talk about the valency later on. Now, graphite structure is formed by the hexagonal array being placed one on top of each other. That is why it gives it a smooth and slippery appearance. Graphite is also a very good conductor of electricity, unlike it's the only non-metal which is a conductor of electricity. You see, graphite is a 2D sheet-like structure. It's a 2D sheet-like structure. Now let's talk about another form of crystalline form of carbon, that's fullerene. The structure is like this, if you all see. So fullerene is another class of carbon allotrope. They are spheroidal in shape and contain even number of carbon atoms. They have the range from 60, so C60, C350 or above. So carbon atoms, they are arranged in the shape of a football over here. So that is all about the allotropes. Crystalline form of carbon. One we talked about diamond, another is graphite, and then fullerene. Now let us talk about what are organic compounds. We heard about lot nowadays that we should eat organic compounds. So what are all these organic compounds? Compounds of carbon containing usually hydrogen, and one or more other elements such as oxygen, halogens. Halogens are chlorine, fluorine, bromine, iodine, all those, and nitrogen, sulfur, and phosphorus. They are called organic compounds. So, organic compounds are the compounds which have carbon together with all these. Might be only hydrogen or may contain oxygen also or other halogen, everything. So, urea is the first organic compound which is synthesized in laboratory. So based on this, we have organic chemistry. So chemistry is divided into two fields mostly, organic and inorganic. Organic chemistry is a branch of chemistry that deals with the study of only organic compounds. Inorganic chemistry is a chemistry of all elements other than carbon and their compounds. Now let us talk about why carbon is able to make so many compounds. We all know that carbon is available in abundance in nature, not in free state, in compound state. You see, everything is made up of carbon. Most of the things, not everything, I would rather say. So why carbon is able to do that thing? So we have some special properties that carbon have. We all know that how we define the reactivity of an element. Element is reactive if it is able to gain or lose electrons. They do it so to attain the nearest noble gas configuration. They have to complete their octet. So elements which form ionic compounds, they either gain or lose electrons. But carbon, if we talk about carbon, what is the atomic number of carbon? Atomic number of carbon is 6. So if we write its electronic configuration, it will have 4 electrons in the outermost shell. Carbon has 4 electrons in the outermost shell. So it has to make it 8. To make it 8, it will either gain 4 electrons or it will either lose these 4 electrons because it will have then only one shell 2. So, but carbon doesn't do this thing. So it does something else. So let us see what it does. Why carbon shares its valence electrons with other atoms of carbon or with atoms of other elements? What does carbon do? Instead of losing and gaining, it shares its electrons. It shares its electrons with other element. So why it is sharing that thing? Let us talk about that. Now, if carbon gain 4 electrons, so number of protons, if we check, number of protons is 6, number of electrons is also 6. If it gains 4 electrons, number of electrons will become 10 if it gains. But number of protons still remain the same, 6 only, because they are not doing anything with the protons. So what will happen? It will be difficult for the nucleus with 6 electrons to hold on 10 electrons. It is holding 4 extra electrons. So it is difficult for the nucleus to do so. Same way, if it lose 4 electrons, so number of electrons will be only 2. Number of electrons will be only 2. So when you remove those 4 electrons, so again it is useless for a 6 proton nucleus to hold on only just 2 electrons. So that makes an unstable situation. So therefore, to overcome these problems by sharing electrons, carbon do this thing. So shared electrons belong to outermost shell of both the atoms and lead to both atoms attaining the noble gas configuration. We can take an example. Let's talk about carbon and hydrogen. Carbon needs 4 electrons. So what carbon will do? It will share its electrons. Let me represent its valence electrons by X, 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 X. Hydrogen has only 1 electron. So I'll take one more hydrogen. Let me just erase it from here a little bit. So this hydrogen also will have 1 electron, this hydrogen. Now hydrogen needs only 1 electron to complete its outermost shell. So this is the sharing. It is sharing this electron. This hydrogen is sharing this. This hydrogen also sharing this. This hydrogen also sharing this. And carbon will have now 8 electrons with sharing. So what I made is called as electron dot structure. So I can represent it over here also like this. Each carbon atom is sharing 1 electron from each hydrogen and hydrogen is taking 1 electron from carbon. This is the compound made is methane. We call it as CH4. One carbon is combined sharing electrons with 4 hydrogen atom, and the type of bond formed over here is covalent bond. The type of bond formed over here is covalent bond, not an ionic bond, because covalent bonds are formed by sharing of electrons. Now let us talk about this versatile nature of carbon. Carbon has some special properties. This is how, just now I explained how it makes covalent bonds. Now let us talk about different properties of carbon, which, with the help of which it makes millions of compounds. So first thing is catenation. What is this catenation? Carbon has a unique ability to form bonds with other carbon atoms. So carbon make bonds with other carbon atom. If I take one carbon, it will bond with another carbon atom. It can also make like this. So this is known as catenation. It is forming long chains. These compounds may have long chains of carbon. You can have branch chains of carbon or even carbon atom arranged in ring. Let's talk about 3 carbons if I take. I can make them in ring. That is a ring form. You take 4 carbon atoms. This kind of thing is a ring. Chain will be, if I take 4 carbon atoms, they can be like that. This is branched. This one is chain. And this one is, branched. This is branching, like I'm branching the carbon. So this is how carbon is making bonds with another carbon atom. So making a long chain, this property is known as catenation. Let's talk about the another property that is known as tetravalency of carbon. Tetravalency, we all know carbon has valency 4. Carbon has valency 4. Because of that, carbon is capable of bonding with 4 other atoms. One time it can bond with 4 other atoms of carbon or atoms of another monovalent element. So that tetravalency is very helpful because carbon needs 4 things to be attached over here. So it can either make it with carbon atoms also. It can either make it with hydrogen if I see. So all these things can be happen. That is how carbon is able to make so many compounds. So compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds which have specific properties which depends on the element that is being connected over here. If I remove this hydrogen and I attach it with chlorine, so it will have a different property. It will have a completely different property. So because of that, it is able to make millions of compounds. Next property of carbon is tendency to make multiple bonds. What are these bonds? Let us talk about. We have 3 type of bond: single bond, double bond, triple bond, that we will learn about in the next video. So carbon can make single bond with the carbon, carbon make double bond with the carbon, carbon can make triple bond with the carbon. Double, single, triple bonds means that number of electrons being shared. Here only one pair of electron is shared. Here 2 pairs of electrons are being shared, and here 3 pairs of electrons are being shared. So due to small size, carbon can easily make double or triple bonds also by sharing more than one pair of electron. So which also result in variety of compounds. So there are 3 properties due to which carbon is able to make millions of compounds. One property is catenation. Second one is tetravalency of carbon. Third one is to form multiple bonds. Let us talk about the compounds that are being made now. They are called as covalent compounds. So what type of property these covalent compounds have? Now, covalent compounds, they have low melting and boiling point. The reason for that is that the bond between this carbon and carbon, it is not that as strong as the ionic compound. So this bond is good enough but not that strong, so that its melting point and boiling point is low. Then it is also a non-conductor of electricity, as they do not give out ions. They are non-conductor of electricity as these compounds do not form any ions. They are not ions, they are only formed by sharing of electrons. They are formed by sharing of electrons. So in sharing of electrons, no ions are being formed. Hence they are non-conductor of electricity, because for conducting electricity, we know that when we put the compounds in a solution in water, they give out ions, but covalent compounds do not give out ions, so hence they are non-conductor of electricity. So these are the properties of carbon compounds, that they have low melting point and they are non-conductors of electricity. So this is what is in this first part of the video, that we talked about carbon. We talked about different forms of carbon. We talked about the different properties of carbon, then that why carbon is able to make so many compounds. So I hope it is all clear. So go through the video very well, go through the notes very well, and I hope it will be clear. Thank you for watching the video. We'll be coming up with the next video. We'll learn about different type of bondings and nomenclature.